Hi, capitalized cost. It's one of the concepts that we use in economics and cost analysis to calculate the present worth for infinite projects. So when we have an infinite project that has an infinite useful life, we call it capitalized cost instead of present worth. So what is the capitalized cost? It's a technique that we use it to calculate the present worth, so another name for the present worth, but for an alternative that has an infinite useful life. This technique is most applicable in government and public projects. So whenever you have a project that have an infinite, like government projects, such as building bridges, hospitals, parks, any public facility that will last forever, we call it capitalized cost. We don't call it a present worth, but we use a present worth to calculate the capitalized cost. How we could calculate the capitalized cost? There are 4 steps that I summarized in my textbook about how to calculate the capitalized cost. And these basically are: number 1, find the present worth for all infinite intervals. Any cash flow that has a finite interval, you find the present worth. Whether using Excel equations or using the factor, find P if F is given, find P if A is given, or find P is if G is given. So whether you use the Excel, this is the most technique that I would like you to use, using Excel, using the function PV. And then number 2, convert all non-annual recurring amount into annual worth over one life cycle. What does that mean, one life cycle? We don't need to have a least common multiplier as we did for the multiple alternative that has unequal life. So only for one life cycle. So if we said we're going to rebuild, or if we're going to maintain this building every 5 years, so we do the A for 5 years. Then we'll take an example to explain this. Divide the A values by I to find the present worth, and then I'll add all the present worth together to find the capitalized cost. All right, let's take this example, question 4 on chapter 4, to demonstrate how we could find the capitalized cost for infinite project, and also if we compare the infinite project with other finite project. So the following data is available for 3 different alternatives. Using present worth analysis, find the best alternative. You see, we have 3 alternatives, X, Y, and Z. Each one of these alternatives has initial cost, benefit, and we have a life per year, and interest rate 12%. So if you look into this alternative X, you will see that infinite life for X. For Y is 10 years, and for Z is 5 years. How we could conduct the present worth analysis, or what we call the capitalized cost. Let's start with the first one, the X. Initial cost for X is 2,500, and the benefit per year is 700, N is infinity, I is 12%. So the first step is to convert any infinite intervals into present worth. Well, basically we have only one transaction that is finite. It's only happening one time, and it is in present worth. So we add it, we leave it as is. We don't need to change it. Just add minus 2,500. This is the initial cost. And for the benefit per year, we have a $700 benefit per year, and this is where we need to convert it into capitalized cost, into a present worth. And the capitalized cost for that would be 700 divided by 12%. 12%. So the capitalized cost, I'm going to write it here. It's an equation. It's listed in the textbook. However, we have to mention it here. We have to include it here. So capitalized cost is equal to A divided by I. A is the uniform series, or the annual payment, or the annual benefit. So what we did here, we divide the 700 by I, the 12%, and then we add these together to find what would be the present worth for the infinite alternative. Now for Y and Z, that's a different scenario. We will have to find what would be the capitalized cost, because we need to assume these projects will go forever. However, these not forever. So what we need to do, first of all, for the initial cost, what we have to do, we have to convert it into A format. So we use the payment function PMT for 12%, 10 years, present worth is negative 2,000. And then divide that by I. As we said here on this right side, capitalized cost is to find A divided by I. So what we're trying to do, we're trying to find what is, if we're going to keep buying the alternative Y again and again and again and again and again for infinity, because we have to have an equal lifetime. We have to be fair when we evaluate alternatives. So in this case, even the alternative is not infinity, but however, we could buy it, assuming that we could buy it for infinity time. So what we could do, first of all, the initial cost converted into A by using the PMT function, divide that by I. And since this is a negative, you have to have the final result as a negative. So if you see a positive cash flow here, just change it into negative. So again, what we did, we converted the present value, the 2,000, this is initial value, initial cost, into A format, and we divide that by I. So we divide that by 12%. And then for the next one, the next transaction for alternative Y is the 300 benefit per year. This should be a positive transaction. So what we do, we divide that by I. So only dividing it because it's already in the A format. Again, one more time here for the present, the initial cost, this is not an A format. This is in a present format. Therefore, we have to convert it into A format to divide that by I. And how we convert it to the A format, we use the PMT function, and this is how you convert it into A format. In order to find the capitalized cost, you divide it by I in order to find the capitalized cost. And what is the capitalized cost? Is assuming that this Y available forever, and you're gonna buy it every 10 years forever. This is what is the capitalized cost. So you add these together to find out what would be the capitalized cost, which would be 449, and this is a negative. Same thing for Z. For the initial cost, we have to convert it into A divided by I. So use the PMT function to do that. Divide that by I to find the equivalent for the 3,000. If we go on to buy it every 5 years forever, that would be 69.35. Now the other transaction, which is the 600, we have to divide that by I to find the capitalized cost. It's already in the A format. There's no need to use any function. Use it as is. Add these together to find out that would be 1935. Okay, so now we have the capitalized cost for X to be 33. Capitalized cost for Y would be 449 negative, and the capitalized cost for Z is 1935. Of course, the decision should be made of selecting X because it is the best decision. This will give you a high capitalized cost. Now, some people, they're still not sure how to calculate the capitalized cost for Y and Z. Here is another way for doing it. Method 2 as listed here. What we did, so alternative X, there's no way for doing it. That's the only way for calculating the capitalized cost. The initial cost, which is already in the present format, the yearly benefit, we should convert it into capitalized cost by dividing A, which is the 700, by I. So that would give us $3,333. So there's no other way for calculating the capitalized cost. That's the only way. And this is basically you following these 4 steps in here. Now, another way to calculate the capitalized cost for the finite alternatives like Y and Z, you create the cash flow as we've learned in other examples. You calculate, you list what transactions happening on year by year for 10 years for X, for Y and Z. So now 0 to 10, and then the same thing for Z. And once you listed all the transactions, so please notice that we will buy another Z on year 5. And then once you build your cash flow, use the NPV function, NPV, to find the present worth of these transactions. NPV 12%, select the value from 1 to 10, add to that year 0 to find what would be the present worth. Now, in order to find the capitalized cost, what we have to do, we have to divide A over I. So in order to find A, we have to convert the present worth to A using the PMT function. So we use the PMT function, 12%, 10 years, and we use the value that we just got from the PV function, and that would give you 53.97. Now you can apply this equation. C, the capitalized cost, or CC, is equal to A divided by I. So once you find the A, you can divide it by I, and that would give you the same result. If you notice, 449. Do the same thing for Z for 10 years. Find the present worth, and then once you find the present worth, you find the A using the PMT function. And once you find the PMT, or the A, the equivalent A for this present worth, you divide it by I of 12%, and this should give you the same answer, 1935. Another way for doing it is I'm gonna stop right here. I hope this makes sense to you. Follow the directions, and you should be able to conduct capitalized cost for infinite alternative and finite alternative. If you compare infinite with a finite, now this is the way for doing it. So this is how you do it. So I'm sure that you will do it. Please let me know if you have any questions. Thank you.